missed what you said then.
I'd like to know how much it takes for that auto level to be off to make something appear over a 5 mile distance or 6 miles or whatever, to make something appear to be going up or down in the distance.
A smidgen.
That's what I mean.
A smidgen.
If that thing's off a hair, you can make something appear to go up or down.
And I think what they do is, I think they auto level it where they think it's an auto level, and they think, yeah, that's close enough. And then what I think they do is they look through it and they think, that doesn't look right. Oh, we'll just do it another click. Maybe that must be right. Oh, yeah, that's right now. Well, I think if you was to stand in front of them with the camera and the auto level, so they couldn't have a target in the distance to line it up to. Well, they don't need the target to line it up to because it's just supposed to auto level. So let them calibrate it without having a target, because I'll be stood in front of it. And when they've calibrated it, then I'll move out of the way and we'll see where it lines up.
Yeah, I think that might be a good idea. If you can be there, then that would be great.
Yeah.
I don't think that will be any problem at all. You should do that, Ranty.
You think I should do that?
Sure, if that makes you feel better, yeah.
I do, yeah, because I don't feel that you would. I feel that if it was to be calibrated and it was to say, and you had a target in the distance and you think, yeah, that looks about right, and then you look through it and you think, that looks a bit too high. Oh, we'll just tweak it. Maybe it needs a tweak lower, and I feel that's what happens. So,
yeah,
well, no harm in making sure, Ranty. That's for sure.
Yeah, level is just perpendicular. It's a local measurement.
Okay. So for the audience, so I don't know if you guys can see my screen right now. Let me show you this. So this is when I took the water out of the tank. So instead of me doing a prior comparison, this is when I took the water out. You can see the water's been lowered to this level here, and you can now see that the top of the tin and that, you can see where they are in relation to each other. So when the original image where the tin is up here and you can read all the word primer, that's because of looming from the first initial application of sugar. Can you see that, guys?
Yeah, I can see it.
So we created a gradient at the top, a density gradient higher at the top, which created this looming effect. Pretty cool. Took me by surprise when I saw this, but Travis had assured me that that's what had happened, and when I went back and I removed this water, sure as eggs were eggs, this was the result. So it had to be looming originally, resettling back to normal afterwards. So yes, looming can happen, but not in the way they tell us, because you need the density gradient to be denser at the bottom to match reality. In this case, it was higher up.
So Ranty,
Rumpus's only answer to that was that you can't know the hot water would go to the top, when that's always what
what happened is, on the second test, what I did is I bunged all the water. So here I am, I'm setting up the second. Oh, actually, I better share my screen so you guys can see this. Otherwise, you're going to miss this. So this was the second test that I did. I've emptied the tank, and obviously, I've now put two objects inside the tank, so I can get a perfect level across the tops. Let's go back. Let's go to the next video. As you can see, this is the position of everything, and let's go further on. At some point, I will keep getting it till I'm absolutely perfectly lined up with the top of these two. And I'm satisfied now that this is the position where I need to film it from. So can you see these two objects are in the tank? And because of the same height in the tank, I know that I'm zooming across them and they are perfectly in line. Yeah. So that's the image before any sugar solution goes in. And then what I do is I bung a whole crap load of fucking sugar solution in. Where are we? I'm trying to get the right once I start it. So here I am. I'm showing that it's all level. I've got it on my phone camera to show this is the case.
What is it you're trying to show anyway with all this?
So let me. So this is doing tests. Brenda. She's just doing tests.
Tests
So-
of what?
Well, let me just finish it for the order. If you're not up to date, I'll talk about it in a moment for you. But this is me just applying some water. So I've stopped applying the water. This is not sugar solution. This is just water in the tank. So this is at this point. There's this much water in, and then I keep pouring more water in it. So this is straight out the hose pipe, and as you can see, it doesn't change the position of the Johnston's tin in relation to the pots in the foreground. So that's just fresh water.
It looks like your camera is low.
So here we are. Here's the measurement for the amount of water that I've actually got in the tank. I think, is it this one that I start to pour the sugar in? So now I just zoom in to show you what it looks like as I zoom in across everything. So this is just with water in. And at some point, hopefully soon, I'll just bung a whole lot of sugar solution in. So this is all the lasers that I've set up. I've got 3 different lasers. One's angled up, one's angled down, and one's absolutely perfectly plumb level. I've got that on my phone as well, so you can see these 3 different lasers that are going through the tank. And then what I do is I pour the sugar solution in. So this is me applying 20 kilograms of sugar solution into this tank. And when it settles, in a moment you'll see that it comes through. Hang on. So when it's all settled down, you've got this little bit of looming that's in the tank. Let me get to a part that you can actually see. Have I zoomed in there? Yeah, so I'm going to go back to the other video. So I must return. Okay, so this is what the camera's picked up. I've then zoomed in to have a look what's going on here. This is the looming that's going on inside the tank, right? With all that solution just poured in and not stirred, right? You can actually see that the word primer is above the tin, and you can see that
Can't read anything. It's all blurry.
You can read primer there, so it's definitely been loomed. So
yeah, it's a bit fuzzy, but you can read it.
Yeah. So then I stir the tank, and I give it a right good stir it all up, and then I'm doing all the laser tests again to see where all the lasers match up. I'm showing you on my phone where everything is. But basically, when I've stirred the tank, can you see how after I've stirred the tank, it's gone back to normal, original? Like before I did, when there was no water in, when it was just water in. So now I've got a uniform gradient in there. And when I didn't have a uniform gradient in, I had looming, and that was at the top, with all the hot water that I poured into it. So, pretty cool.
Yeah, that's awesome, Ranty.
Ranty, what would you... When you remind us that the warm water was at the top, how do you associate that with the effect of looming? How would you explain that?
Well, the warm water, the boiling water that's poured over the sugar. So you stir it and you stir it and you stir it until all those the gaps inside the water molecules fill with sugar, right? So that's how it's dissolved, and it's dissolved to the point of saturation. So that 20 kilograms of sugar that I poured in, which was around about 14 liters of water, boiling water, should I add, was all poured in at the same time. And in the first experiment too, was poured in individually from the top boiling water, and it all sits at the top. We all know hot water rises, and then so all that hot water is at the top, but it's all filled with sugar, and it sits on the top. It doesn't sink because the molecules are filled with sugar, and it's hotter than the colder water underneath it, and it sits at the top. So we've been able to invert it. Now, what Travis is going to do, what Brandon's going to do, is he's going to start dropping sugar into the tank, just filled with water, drop some sugar in it so it lines the bottom of the tank, and that will create a gradient from the bottom up. So this time it will be the inverse of what we did when we poured the boiling water from the top and created the gradient from the top down.
So molecules don't get filled with sugar. That's not how molecules work. And If you've stirred it up, it's going to be uniform gradient.
Well done, Brenda. Thank you. That's exactly
Yeah, well done.
that's exactly what I was trying to do, Brenda. That's what I was
Yeah.
trying.
So
jeez.
I was
what is
trying.
it? Yeah.
I
So
was trying to create a uniform layer to see if it was density that caused the sinking. Right. That's what I was trying to attempt,
if it
and
was
I managed to
density,
attempt
well,
it.
it's the
And
change in
so
it's the change in density that causes refraction.
yeah. So here's the final result, guys. Here's the final result. I think this is the following day. All the lasers are in the same position. The tank is all absolutely pristine, and it's in exactly the same position with all that sugar solution in as it was when it just had water in it, right? So the density of the tank didn't make any difference to the observation once it's uniform. But when it's not uniform and we've got a denser region at the top, we get looming when it's
Okay.
at the top.
That's how looming works.
So you agree then that it has to be
Thank
denser
you.
at the top? That's cool because
That
we don't
what?
have a denser atmosphere at the top, Brenda. The atmosphere is densest at the bottom.
Are there weather conditions where that's
Yeah, but
the case?
how
Where
often,
you
Brenda?
I don't know.
How
And
often,
you
Brenda?
don't have. I don't know.
Yeah, Brenda, you're talking off the top of your head. You have nothing upon
Yeah.
which you are basing your comments right now.
So
She's
You're
just
out of your
hoping
depth.
she can
No.
throw shit at the wall and hope something sticks.
no, I'm trying to understand what he's saying.
Yeah.
I'm just trying to understand. So the point you're
We know
saying
you're
that you
trying
had
to understand. You just don't, though.
But that's fine. Listen, if you're halfway through this, Brenda, that's cool because the people that are probably involved with this and that are interested in this thoroughly understand what's going on. You might need to catch up and get up to
so
speed
you could
on it.
explain it to
But
me
this
then.
is an ongoing. Well, this is an ongoing line of research, Brenda. What we've demonstrated is that the dense gradient at the top creates the looming, but we don't have
No,
dense
that's not.
gradient.
No, it didn't. You didn't have density at the top.
You're trying to understand, but no, he's wrong.
Yeah,
Okay.
You didn't
exactly.
have density at the top
Exactly.
because you mixed it up. You mixed it.
She said well, not
He's got
understanding.
two
After.
different tests,
Oh, Brenda, that was after.
you mong.
That was
Fuck
after,
me.
Brenda. That was the second goal. Brenda, you're
Like
not with it.
a child who
She
wanders
Yeah, you
literally
into
didn't
the
doesn't
have-
look
you
at
didn't have-
what you've
how did
done
you-
and then comes in try to tell you you're wrong.
How did you have
And she doesn't even know what she's
No,
talking about.
go watch the videos, Brenda. Stop asking questions.
So how?
go watch the two
There's
videos.
nothing wrong with asking
Stop
questions.
asking. No, it is because you're not willing to listen and learn. You're not.
How was there a density gradient at the top?
Because we applied boiling water to the top. And that was like an effect that we didn't take that into consideration as to what effect that would have. I certainly didn't. And but now that we understand what's going on, you know, the saturated
Did you
water
measure?
that's full of sugar. Hold on. Yes, we did, Brenda. The saturated sugar that Brenda, we'll get to this. So the saturated sugar at the top that was, obviously filled with boiling water, stayed at the top.
How?
And then the more sugar,
You don't know that. You don't know that.
and then the more sugar solution that you applied, it returned to normal.
I love hearing them deny their own science that,
No,
hot
I'm not-
doesn't rise. You can't know that hot
Hot not rise,
rises. Wow.
You don't know that. You don't know what happened.
No, of course we
Brenda,
don't know that. No.
Have you had a bath recently?
Fuckwit.
Have you had a bath recently?
Yes, I've had baths.
Cool. So when you get in the bath and it starts to go cold and you turn the hot tap on, it only warms the top part of the water because you can never get it to go down to your bottom. No matter how much you try to force that warm water to go and warm your bum up that's gone cold, it doesn't work because the warm water rises to the top.
No,
And it
that's
doesn't
not true.
mix.
That's not
That's
true.
true.
No, it isn't.
That's true. Trust
No,
me.
it
Yes, it's
isn't.
true.
No,
it is true,
isn't.
bro. It's
not
true,
true.
Brenda.
Oh my God. Well, you're talking to the
eventually-
woman who said that the two images that were identical weren't identical. You can't trust what this woman sees or thinks. Like, she's literally insane.
I think I know what Brenda is saying, and I'd like to rephrase her question, Ranty.
Yes.
What I know, and I could be wrong, that the less density is the less refraction index. So if the hot water is less dense, it should be less refraction index. But the sugar also increase the refraction index. So we have two opposing factors.
Yes,
And
that's right.
we don't know. That's what we don't know. So maybe we can do another experiment with
Well,
just pouring hot
pouring
water.
hot and cold water. Yeah, that's what we're doing. We're going to do that. So you're absolutely
Perfect.
spot on there. But one
Okay,
thing
so
one thing we've pretty much been able to demonstrate is though that once the water did cool down, because it did cool down eventually, you know, but you're only putting in to start with like 1 in every 30. So there's 30 litres of water in. You put 1 litre of warm, well, boiling. So it's not an awful, you know, it doesn't take long for it all to equalise and all the temperatures sort of like become the same. And even if we left it, even though we left it for hours, you know, it essentially stayed the same. So each result was the same. So the temperature didn't affect it as much as the density. The density changed it more than the temperature.
Ranty, just because you mentioned this illustration, it's actually in my head right now. So I think that I can relate to what you said about running a bath. You know, I run a nice hot bath. I get in, then the water gets tepid, and I'm like, hey, I'm gonna turn on the hot water again.
Yeah.
You know what I find? You know what I find that happens? I find that the surface of the water, where my knees are and my neck and my arms, I can feel the heat there. But down at my ass, it's not down there.
No, that's right.
Yeah, exactly.
Yeah, it's kind of like what you said, right? I think I've experienced that.
So how did you verify that the hot sugar water, dense water, was at the top?
Because it's the way we poured it in from the top, Brenda, boiling water. It instantly stayed at the top. It didn't go down to the bottom.
Yeah, how
And
did
it kept
you
all the
verify?
sugar.
How did you
Listen, and it
verify
kept all
that?
the sugar with it. It kept all the sugar. Well,
Yeah,
it's
how
more
did you
research,
verify that?
Brenda. There's
Yeah,
more
didn't you hear him
research.
say he's going to do it again with hot and cold?
Yeah, there's more research.
Like,
to
this is
do, Brenda.
ongoing.
So you didn't verify it.
There's more. Yeah, well, as
It's
each
common science
incremental.
knowledge that hot water will rise. That's just common knowledge, Brenda.
Yeah. So you
Well,
didn't
put it
If
this
you're
way,
going to start
I'll tell you-
denying science like that, then you really have no business here.
Well,
Brenda.
if it had been the other way, Brenda, the more sugar solution we applied, the more looming we'd have got, right? But what happened was on the first application of sugar into the solution created, 1.5 kilos of sugar gave the looming the most looming effect, and then the more sugar solution that we put in, it returned it to normal. Now, if it was sinking to the bottom, Brenda, right? It would have done the reverse. It would have just increased.
The opposite, yeah.
It would have given you more.
No,
right?
looming is what you get when you have density at a density gradient where the densest part is at the bottom. So you got looming. So you have density at the bottom.
Do you have a citation for that?
That's
Brenda?
what he's shown is wrong. He's done it the opposite.
No, but he just
You have a citation for that, Brenda?
He just described the conditions
Where did
for
you get
looming
your information
properly.
for that?
Britannica.com.
Out of her ass.
At my ass.
See, I've got all these lasers.
Well, hold on, Brenda. You don't have an answer for that. How are you able to declare?
I said Britannica.com.
Britannica.com for looming.
Yeah, the density is at the density. You have a density gradient with the densest part at the bottom and getting less dense at the top, right? That causes looming.
Okay, so did they give you a citation for the research that went into that, upon which they're basing that entry? Or was it?
Well, if you want a proper site, it would be Andrew Young's website. Would be the proper site.
Yeah. He doesn't do it either. He tells you.
Yeah, he does.
That's what's. No, okay. Listen to me very carefully. He tells you what he thinks is going on. He does not show you any measurements. He does not show you any research. He does not give you any links to follow up and verify what he says. Okay?
Yeah, these are things you can check for yourself for one thing, and for another, this is
Oh,
basic.
we have. Ranty's just done it and showed they're wrong.
No, this is basic science. And Ranty confirmed that when you have dense medium at the bottom, you get looming. That's what Ranty just did.
Oh my God.
Just completely ignore it.
Seriously, guys?
You're a gaslighting
are we really going to
psychopath.
put up with this?
You are a psychopath,
insane. Absolutely insane.
You're a
What?
pathological liar.
Yeah, pathological liar, psychopath, twisted, insane.
No, you
So
poured
this,
you poured a
this
dense
Britannica
medium.
website.
You've had a psychotic break.
No, you poured a dense medium into the water, and so it's at the bottom because it's denser.
No, it stayed at the top, Brenda.
No,
you didn't
It
verify
stayed
that.
at the top, Brenda. It
No,
stayed
you
at
don't
the
know
top.
that. You
Well,
didn't
then shut
verify
your
that.
mouth until he does the next one. Well, shut your mouth until he does the next one, and
So
then
you
you can
don't know
talk about it.
that.
Until
You
then,
didn't
you've got
verify.
nothing.
You didn't verify that. You don't
Yeah,
know
your
that.
science
Just real
says
quick,
hot
Brenda.
always rises.
Brenda, just
so
real
yes.
quick, Brenda. Brenda, just real quick, Brenda. Have you ever gotten into a lake where the top of the water is actually pretty warm, and then about 6-8 inches below, it's very cold?
Or even a swimming pool, Travis.
Yeah. What are the conditions?
Yep, absolutely.
Why does that happen? Why does that happen, Travis?
Doesn't matter why. Does it happen?
Because
yes.
the warm water goes to the top.
No, that's
and
not
the
why.
cold water
That's
is
not why.
below. Yes,
that's not
it is.
why.
Yes,
The reason that in a lake the warm water will be at the top is because the sun is shining on the top of the lake.
Isn't fluid constantly moving, Brenda?
Yeah, making the water warm, making it rise to the top. It doesn't get warm and sink.
It's because the
water's
sun is
not
warming.
static.
It's because the sun is warming the water at the top. That's why.
Yeah, but it's not warming the water and then the water's going down, is it? The hot water's staying at the top.
It's at the top because that's where the sun is. Because that's where the sunlight is.
But it's not dropping the water down as it gets hotter, is it?
Right, because the sunlight is at the top.
Because
this is not an analogous situation.
Oh my God.
This seems like it would be pretty simple to solve. Can someone just record an experiment where they dump hot water into cold water with a thermometer in it? Or some sort of detection device that shows the two different temperatures?
They've already done that. We know hot water rises.
It would take like 3 minutes,
just
right?
throwing shit at a wall.
It wouldn't be just hot water. It would be hot, dense water. That's what Randy.
It doesn't matter. All we'd be proving is that warm things go up.
No, it matters because dense things go down.
You should be at the very bottom then.
Don't get much denser than you.
Right. So the dense hot water was at the bottom.
No, it wasn't, Brenda.
You didn't verify that.
Did you?
And you can't prove what you're saying either. So.
And you can't verify anything you say. What about
you,
the
Brenda?
gas pressure next to a vacuum? Did you verify that?
Yeah, nobody claims there's air pressure next to a vacuum. Nobody claims that.
Yeah.
That's not the global claim.
Can't even show a gradient of atmospheric pressure near.
Yes, you can. Yes,
you
can.
can. So they can't show anything.
Yes, you can show a gradient of air pressure. Yes, you can.
That's not what I said.
So we know. Since you didn't verify it, the most likely thing that happened is that the hot dense sugar water.
No, you're just now telling a story.
She's
dense
throwing
water,
shit at the wall, hoping something
the hot
sticks.
dense water went to the bottom.
This is what's most likely to happen because I say so. You idiot.
And we demonstrated looming, which confirms that the hot dense water was at the bottom.
Now, you don't just get to make a statement and then draw a conclusion, Brenda.
I draw conclusions based on prior knowledge. I know how refraction works. Refraction works because light passes from one density medium to a different density.
Who was speaking then? Because you were really low.
Is it me, Ranty? I don't. Has my
Who are you
mic check?
to then?
Yeah, that's better. That's better.
To Brenda.
Right. So what Ranty?
I was just saying, Brenda was making. Hang on. Brenda, just hold on 1 second. You just made you made a claim about what Ranty did and said, "Oh, Ranty, you didn't verify it. Therefore, this is what likely has happened." And then you just go on to tell a wonderful shush. You go on to.
I was just agreeing with him. That was all.
Evangelist, Ranty.
No, it's based on prior knowledge of how physics works.
Well,
the fact that you demonstrated the fact that you demonstrated looming shows that the denser sugar water was at the bottom.
I can hear him.
Right. Okay.
Well, you're wrong.
Yeah, the hot, dense
My
water.
point, Brenda, is you make a claim about what Ranty has demonstrated, and then you say, no, that's not what's happened. You haven't verified it. Now I'm going to tell you what's going on. You don't just you don't have a pedestal to stand on and just pontificate to everybody.
No, it's based on. It's based on.
You do, and there we go. That's where we show the just a break from reality that you live in.
No, so allow me to
You live in La La Land, mate.
Right. So allow me to explain.
Honestly, I feel sorry for you. I'm not talking to you anymore. Goodbye. You're an idiot.
Yeah. Allow me to explain. It's based on my prior knowledge that looming is caused when. Excuse me. Just let me explain my position so you understand it. Looming is caused when you have a density gradient with the densest part of the medium at the bottom. Ranty didn't verify. He simply assumed that the dense water went to the top, but he shows looming. Therefore, that proves.
No, it's prior knowledge about what water does.
Right,
almost
guys,
there.
give me a
Almost
second.
there. Almost done. Therefore, it proves that in fact he
you're
was
way
wrong.
past
No, it doesn't
that
prove
the
it.
dense medium must have gone to the bottom.
Everybody, be quiet for a second, right? I want to walk. I want Brenda to look at my screen right now, please. So, I want her to tell me what's happening with these set of images, please. So, can you see my screen, Brenda?
Yeah, I can.
Right. Okay. Cool. Right. So, this was the first image. Right. This was the first image. Right. So, what's happening here, Brenda? This is what we're looking at when there's no basically any sugar solution. It's almost the same because there's a small bit of solution in. Would you agree? If I show you the control.
What are you saying? The lower image, and you have
Hang
a lower
on.
image and an upper image, right?
Let
I don't know the difference. I don't know the difference between them.
Let me just find an image for you. Just bear with me. Hang on.
One's
Right,
lower,
here we go.
One's upper.
Right, here we go. So
yeah, it's amazing how
this is
simple you have to make it for her.
This is the setup. Without you can see that the water's been removed, and basically this is where
I can't tell that. The water is clear. I can't tell.
Right. Okay. Well, there's water here. I'm not trying to fool you. I'm trying to be honest with you. That's where the water is. Right. You can see there's water there on this one in the background. It's there. It's going up so far.
Okay, hold on, Brenda. Could you really not tell there was a reflection on the surface of the water? Could you really not understand what Ranty just said to you when he said the water was taken out of the tank?
The water is no. What are you talking about?
Most of the water is removed from the tank.
Oh my God!
So all we're trying to do,
Brenda.
My stream must be behind
Brenda, listen
yours.
to me.
Listen to me, Brenda. Something different.
Listen to me, Brenda. All I'm trying to do is look at the relationship between this pot here, right? That pot there, and the tin in the background. That tin in the background. That's all I'm trying to do. We now have, most of the water taken out of the tank, but it's not. The water is not affecting. We're looking through obviously some glass, but this is the image, as you can see, right? Can you see the relationship between these two? Can you see that?
Yeah. Why is the near cup is higher than the far cup?
Forget that. I'm not looking at that. This is nothing to do with that. I'm looking at the relationship between this and that.
And it's because they're the same size cup and one is a little bit further back, therefore reducing its angular size because of perspective.
That's not how that works.
Hang on.
Me.
Wait a minute.
Yes, it is.
Open with...
My God, I cannot believe that people like this actually exist.
Actually...
I can't believe we entertain it.
Actually...
It is entertaining though, Paige.
Well,
hold on,
I was gonna say, guys, that he was there to listen, and the next minute he was an expert. Suddenly, I mean, sorry.
Does this help, Brenda?
Yeah. Sure.
Right. So let me just take that image there. I'm just going to take that image so we can just see it, right? Right. So Right, and then I'm going to go back to this image over here, right? So I'm going to paste that there so that you can basically see. So this is with no nothing in the tank, so you've got a clear line of sight. And this is an image here, right? Can you see how closely matched they are? Would you agree that there's no real difference between their approximate heights to each other? It's not a trick question.
Yeah, the rim of the paint can is slightly above the top of the cup.
Yeah, I'll agree with that. So it's slightly, but there's not a lot of difference. But look what happens when I move this image up to the next image here, right? So I haven't changed the camera position at all. But can you see there's a difference here, Brenda?
Yeah, that would appear to be looming.
Yes, that's right. So let's go a little bit more. And then we go up to the next one. Let's go to the top one, actually. Let's go to the top one. So we've got 4 separate images here. So I'm going to zoom in now. And can you see a difference here? Can you read the word primer on the left-hand side? And
they're both pretty fuzzy. They're both blurry. But I can see the black label. I can see the black label with the white smudge in the middle.
Yeah, so it's much higher. So it's definitely loomed up, isn't it? Right?
Sure.
That's what we're trying to say. Right, okay, so that's cool, right? So here's my question to you, right? So here's with no solution in. How much sugar solution is in this? If you was having a guess, how much sugar solution would you say? If you said there was 10 kilograms of sugar solution put in this tank, how much sugar solution?
Well, I have no idea. I have no idea how much would be in there, but it's obvious that the can on the left is being stretched up. It's being loomed upwards. Yeah, that's looming.
Okay. So
it looks like it to me anyway.
Right, okay. So what I'm saying is there's more looming at the top one, isn't there? There's more looming up here. This is definitely loomed up more than the bottom.
Sure.
So is that with more sugar solution or less sugar solution?
I have no idea. I have no idea.
Well, what would you think it would be?
I have no idea. Did you add hot
water?
Thought
she was
too?
an expert.
I need more information.
Yeah, I thought.
Did you add hot water?
Each of these had more solution. They had more solution put in in each of these 4 images. This is basically the control image. This one that I'm moving around here.
Okay. So
that's the control.
The looming, the control is no sugar.
Yes. So this is no sugar, no water, because that's below the actual tin. It's down here, so it's not affecting it. We're just looking through the tank right now. So we're just looking through glass.
I think my YouTube is behind what you're saying, so there's some confusion to that.
Why don't you watch the Discord?
Yeah, I'm presenting it in Discord, Brenda. I thought you was watching it in Discord.
I'm watching it on the YouTube thing.
I'm
it's not
watching
that far
it in
behind.
Discord now. I'm watching in Discord.
Right, okay, so you're watching it in Discord, right? Okay, so the image that I'm going to roll around now, that image there, that's the control, right? So that's just looking through glass, right? So there's no water affecting the rims of these.
And the one on the left, you added just water, or is it sugar water?
It's got sugar water in it. In fact, all of these other images here have all got sugar water in it, right? But I'm asking
increasing amounts.
What from this one? So a small amount in this one, and then it just gets a little bit more, little bit more. The more sugar solution you put in, the more lumen you get. Okay.
So you've increased.
Seems logical, I suppose.
Yeah. So you've increased the index of refraction.
Okay, so by applying more sugar solution in it from this one down here, so put a little bit of sugar solution in that, you get a little bit of rays, and then a little bit more, it gets more.
You've increased the index of refraction.
Well, that was the wrong way, Brenda, because this was the little bit of sugar, and then I added a little bit more sugar, and then that was that image, and then I added more sugar solution, and it was this image, and then finally, after I piled loads of sugar solution in, I got it down to this image here.
So that was the hot water. That was the hot water then, right? That was the hot sugar water.
All hot sugar water poured in from the top, Brendan. And you told me that the sugar solution would fall to the bottom and create a density gradient from the bottom. And, the more sugar solution you added, then obviously it would increase like so. What we found is that when we applied the hot water from the top, we got this effect with a small amount of sugar, and then the more sugar solution we added, it started to lower the image back down to normal. Now that's telling us, Brenda, that the gradient was from the top and not from the bottom. And that would agree with you when you said that you would think that it would be this way around.
Yeah, I'd have to know more. I'd have to know more about what you actually did.
But, well, it's just because, you know, as a logical way of working out where the density gradient was inside the tank, you answered it quite clearly when you said that when you apply it from this way up, this would be logical, but it was the other way around, proving that the density was at the top rather than at the bottom.
Right. So you need to spell out clearly what it is you did, right?
I've just told you.
He just did. My God.
This bottom one had.
Brenda, you've exploded and blown your guts all over the walls, and you don't even realise it.
Yeah, this had about 15 kilograms of sugar in. This had about 15 kilos of sugar in this bottom image, and the top image had just 1.4 kilos. So 10 times less sugar in this one, but created this looming effect. And the more sugar solution we put in, it returned it back to its normal, telling us that the gradient was started at the top of the image. And if you invert that, then that would be sinking, not looming, because our gradient is from the densest part, not the less.
So you poured in hot sugar water in each case, right?
Exactly the same. Exactly the same. Hot sugar solution from the top, not stirred, just poured in. Every single time. Recorded on a phone camera and the P1000.
Okay, so it's your contention that hot, dense sugar water was at the top, right?
Yes, that's correct. Well, Brandy, you've just agreed that you would suspect that this would be the case, that this would have the least amount of sugar and the top one would have the most in, but it was the other way around, Brenda.
Okay, well, I possibly was wrong. So what you've done, though, is simply to show. What you've done is to show what we would expect. If you have a denser medium at the top, you would expect it to do sinking, right?
I'm sorry, I'm just laughing at
you. Would expect sinking. No, there's no problem. I don't have a problem with admitting I might be wrong. I don't have a problem with that.
Well, nor do I. We're just.
You shouldn't have. That's
right. So I don't have a problem
to you
with that.
people that you shouldn't have a problem, but you do.
I don't have a problem with it. I just admitted that I might be wrong. I might be wrong, but you're saying that you had hot, dense, and dense sugar water at the top, and progressively more as you go down, right? And so that creates a sinking phenomenon, right?
Well, it does in this setup.
Right, so that's in line with what we would expect.
Hang on, let me just invert this image.
So as I understand,
no, Brenda, it didn't create sinking. Brenda, it didn't create sinking. It created looming. No, sinking.
It isn't. The looming is
the
at
base
that top.
picture was the one with the bottom thing,
Yes.
The looming is at the top image where he says there was less sugar water, right?
That's correct. Yeah.
And that as you go down, it sinks, and you would expect that. You would expect that because you had a dense gradient at the top, so that's would be expected.
So the dense gradient was at the top. Thank you. So we are correct that the hot sugar solution kept the densest part at the top and kept the sugar at the top, creating this.
Yeah, I agree.
Effect.
I agree. If that's what happened, then that's not out of line with what we would expect.
You don't. No,
hold on. Don't interrupt. Don't interrupt, guys. Don't interrupt. Just one sec. Right. So let me just crop this. This is the main image, the first image with the most looming, right? So now we've got the dense region here. So we've got the dense. Let me put some dense region in. So this is the dense region. Hold on, Brenda. So this is the dense region. Let me put that in. This is dense at the top. So I'm going to put this red bar in. So that's the dense region, and that's created this looming effect. Yeah.
You said that this image is with no sugar water, just a little bit of sugar water.
This had a little bit of sugar.
Just a little bit. Right.
Yeah.
So that created that was looming, right?
Yep. So
and as you increase the density at the top, it's sinking more, and we would expect that.
Yeah, but what you're forgetting is that if I rotate this 180 degrees, this is reality. So this is where we live in the densest region. So the red line that I've now put in at the bottom is now reality. So we have a dense solution. We have dense atmosphere where we live at sea level, and then the higher up we go, it gets less. It gets less dense. So we just inverted the tank to create reality, and instead of looming, what we're actually getting is sinking.
If you invert it, it's not sinking anymore; it's looming.
The image is sinking; it's being dragged down.
No, it's moving up.
No, it's.
Oh my God!
No, we've just through a series of different images. Showed you this.
So what you said is that this image, right side up, has the most looming in it and the least amount of sugar water, and as you increase it, it sinks to be close to level with the cup.
But now let's put it in.
That's what we expect. That's what we expect as we understand refraction. That's how refraction works.
Yeah, but
Brenda.
No, Brenda.
Yes, it is how refraction works.
You take it over, guys, because you take it over here, because I'm getting hoarse talking. So, do you guys want to crack at it?
Sure. That's the exact opposite of what you said earlier when you were claiming that we didn't verify that the hot water sank.
Yeah, I don't know. I'm just going on the assumption that what Ranty says correctly describes what he did. And if that is true, then he's done nothing remarkable. He's simply verified how refraction works. If you have a dense gradient with the density at the top, you'll get sinking.
So
but
you're not that clever that you think you're fooling us, that you're playing stupid and blowing with the wind your opinion any which way you think supports the globe.
I'm accepting.
I don't think
you have
it is
no
playing
interest in an honest intellectual conversation.
I'm accepting.
And you're just talking shit to waste time.
No, I'm accepting what Ranty says he did. I'm accepting that. Ranty
How come
says,
you didn't accept it when he said he poured the hot water in and stayed on top?
Doesn't matter. Something. So I'm accepting that what he says he did is what happened, that he had a increasingly dense gradient with the densest part at the top, and that would create sinking, which is what we observe.
Why would the first batch, when you poured in the first hot water and the density is at the top, create looming?
Well, no, he didn't have
There's a little flaw in your logic.
He said he had very little sugar water. It was right.
So he poured. There was no sinking. There was no looming when he started. He poured in the sugar water and it loomed up. So that's the first batch of hot sugar water that's sitting on the top. So it's got that opposite gradient as the Earth, and it's creating looming. Correct? Right, you just agreed.
So that's the difference between the air as the medium and the water as the medium.
Oh, now it's the medium. There you go, blowing in the wind again.
The change in the density of the medium is what causes looming.
You're so full of shit. She's just saying anything that comes to mind just to waste our time and obfuscate and confuse people.
The change in the density of the medium causes refraction.
How many times are you going to say that?
Yeah.
I'm talking about
you understand
just said, well, it makes sense. It lines up because he created a gradient from the top, and as the gradient went down, the looming went down. But you didn't account for the first time when the looming started, when the hot water was on the top.
The gradient increased in its strength because it got denser and denser at the top, supposedly. So that creates sinking, which is what we observe.
Doesn't make any sense. Does that make any sense to anybody?
No,
this is because how refraction works.
She doesn't understand that the atmosphere itself is densest at sea level, and then it gets less dense the higher up you get.
Yes, but you created the opposite.
Exactly. So instead of looming, what would I have got, Brenda? In reality,
sinking,
instead of looming, I would have got. So I'd have got
sinking, which you observe is sinking.
He created the opposite to create looming, Brenda.
But he didn't get looming. He got sinking.
No, he didn't get sinking. He got lower levels of looming. So he had a big gradient the first patch he poured in, right? It created a huge gradient with the sugar hot water on top, and then the lower colder water, correct? And he got looming. Then he added some more. The gradient got less from the top down, and the looming went down.
Less.
He added more. The looming went down.
He increased it. He increased the sugar water.
I'm done talking.
Yes, and the looming wasting our time. That's right.
Right.
So
the refraction increased.
So what happens, Brenda, when we have reality? We have sinking.
No, we have looming in reality.
Oh my goodness!
Wow!
You created a gradient. You created a density. You created a density
what's happened here is Brenda's just come in to pretend to be so thick to get away from.
I'm agreeing with you. I'm agreeing with you.
Stupid.
I'm agreeing with you.
She doesn't even understand what you're saying to her.
I'm agreeing with you. I'm taking as stipulated that you did what you did.
Okay, so
yes, but you're missing the end of it.
Brenda lives in the upside down.
So you disagreed that Randy did what he said he did when it didn't meet your model, but now you agree that Randy did what he said he did. Now that you think it
when she thinks it meets her model,
What is looming?
Yeah.
Brenda,
convenient.
But she's an expert.
When he put the hot water with the sugar, he created the denser medium on top, so that created the looming. As he poured more stuff, the whole water become even, and that's when you take it back to the normal picture, because now the whole water is the same density. There's no more gradient anymore.
So why are you disagreeing with what Ranty said he did?
No, that's not disagreeing. That's exactly what I said.
No, you said that you had less a very small amount of sugar water in this first image. This first image that we're seeing right now.
Yeah, at that point, Brenda, that little water with sugar, it's more denser than the whole, let's say, the other water, and it's on top and it's creating the looming. As he pours more water with sugar, it starts becoming evenly on the gradient. So it's not denser anymore. Like the whole water is even.
So the reason
and now it goes back to the normal.
So the reason it's looming in this image is because we're looking through water instead of air.
That's the reason. Right, okay. Everybody, that's the reason.
Oh, why didn't you say that to start off with?
I did. You people talk over me all the time.
If only you
break.
You people talk over me all the time.
The point here, Brenda, is that in real life we don't see the denser gradient on. So you never see looming on real life.
We see it all the time in real life.
No. It's the other way around. You just don't comprehend.
Yeah, she just doesn't
looming
understand.
is easily demonstrated in real life. It happens all the time.
Yeah, Ranty did it.
And to be fair, it's not just me that's doing it. Sorry, it's not just me that's doing it. It's
Brandon
Floyd, who's recreating it as well and getting the same results. So, I mean, and I'm sure other people will be doing it as well.
Can I ask a question about your setup? Can I ask a question about your setup? Why do you have the can outside of the aquarium?
I knew that was what she was going to say.
Does it matter?
Yes, it does matter. Yes, it matters. Yes.
How?
Because
matters now, Ranty. Now that you've explained everything else and she's not happy, now it matters.
Yeah, she was happy with looming.
Yeah. If it was what she wanted, then it would be fine that paint can was outside.
Yeah.
Brenda said,
so do I get to answer the question? I was asked a question.
Done.
Can I answer it, please?
No one's stopping you. I haven't got a hand over your mouth.
I've only got a 3-foot tank, Brenda. What do you want me to do when I'm trying to get an observation over about 8
Well,
feet?
you could put your observation. You could just put a strip of a measuring tape up against the glass of the far glass, right?
I suppose I could also go dancing in the street naked as well with a stick up my arse.
That'd be good.
Well, you could do that, but that wouldn't show looming.
Make sure you get that on film, Ranty. I got to see
We can
that.
live stream that. Live stream that, Ranty. You watch your channel members go up.
So the point.
We'll have
so the
all the
point
women
is.
flocking in here.
So the point is that you're getting additional refractive effects when the light leaves the aquarium and enters the atmosphere, the air again.
Blah 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 blah.
Rumpus disagrees with you there, Brenda. Sorry.
I'm not disagreeing with what? What are you talking about?
Yeah, I said Rumpus disagrees with you there because when I was discussing with him on the last show, he said it would have no effect.
Okay, maybe, but it seems to me that you should conduct.
No. Hold on, wait a minute. So if that's the case, maybe not maybe it's just more obfuscation, more shit you're trying to throw at the fire.
No, you should conduct.
All the T's and all the I's have already been dotted. You know, I mean, we've been through all this.
No. Well, then I'm just going to say he's wrong. You should conduct the entire thing within the tank.
Ah, right, okay. Rumpus is wrong. He's getting a lot of things wrong, Rumpus, recently, isn't he? He's getting told off by everyone.
I think I've disagreed with him on some things. So yeah.
Hey, Brenda, I have a question for you. If we wanted to create the sinking effect using this same setup, how would we do that?
You would have a density gradient with the densest portion at the top.
That's what I just said.
That's what you showed is sinking. What you showed is sinking. You demonstrated
it. Was looming, Brenda.
No, it wasn't.
Goodness.
You showed
It loomed up and then went back to normal.
Yes, exactly.
How can you not get this?
It moved up because you're looking through water instead of the air.
Sugar water density. Oh. Jesus Christ.
You get refraction is due to the change in density.
I'm getting tired, guys.
Yeah. For Brenda.
I do have a. Oh, sorry. Go ahead, Crow.
Let the Glober ask first. So this is a serious question. Is there any way to know which is more effective for refraction? Hot water with sugar or cold water? Is there a rule, or is it just density? Period.
I think it's just the way that I did the test. You know, I inadvertently created the conditions for the sugar solution to stay at the top by already getting the sugar and boiling it and having it all saturated in the boiling water, so it was already totally condensed in that water, that pan that I was pouring in from the top. So it had nowhere else to go with the cold water. The cold water, it didn't need to mix. The sugar solution didn't need to mix with the cold water because it was already saturated. All the molecule was saturated with the sugar.
Molecules don't saturate with sugar.
Whatever,
That's
Brenda.
not how molecules work.
Whatever, Brenda.
Yes, but
what do you mean whatever?
But the question,
it's just...
which is more refractive? Cold
density.
water?
You test them independently.
I don't think the temperature has a lot of. I don't think the temperature does much at all.
Temperature affects density. Yes, temperature affects density.
It affects it, but it's density that's the main. Yes, go ahead.
Right, and hot water is less dense than
Somebody's
cold
trying to speak. Hold on, Brenda. Who was that trying to talk then?
That's me.
Who?
Why he
can't hear him.
Who's that?
I can't hear him.
I think that's Crow.
No, not me.
Silent Zero.
Okay, sorry.
It's Silent Zero. There we go. He's just like he's.
No, he's reconnected. He's reconnected now. Maybe he has a better connection.
Hey, is it working now?
Yeah, that's
better. It's better.
All right. I was gonna say, Brenda, the reason why he used the hot water mixed with the sugar is so that the hot water stays on top of the cold water, and it's gonna be denser.
Okay.
That's why you have to do it that way. If you use the same temperature with sugar, it's gonna mixture right away.
I accept that what Ranty says happened is what happened, and it conforms with what we would expect.
And it caused blooming.
No, it caused sinking.
All right, Brenda.
He demonstrated
All right,
sinking.
No.
Ranty says it
from
was
no
looming, so
density
you
in the
have to
water at
believe
all
It
She's
shows
trying to
to a
set
little bit of
precedent into the
density
argument.
caused
the images.
looming.
The images demonstrate sinking.
All right.
No.
Also,
No,
Yes,
it
they
went back to
do.
normal. It didn't
Let me
sink
walk you
below
step.
what it was
Brenda, if you
originally.
accept what Ranty says about it, ask Ranty what's happened.
Yeah, it was the other way around. Brenda's still got it in her head. See, I asked her this.
She's very confused.
I asked her this. I asked you this at the time, and I said, "Where would you expect the most sugar solution to be in this particular image?"
I didn't know.
And I went through. Yeah, but then we went through it, and I said to you, this is the control, and this is an image, and this is other images, blah 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 blah. And you agreed that the more sugar solution you would add to the tank would be the more looming. So the one with the greatest amount of looming, you expected that to have the most amount of sugar in. It was completely the opposite.
Right, I'm
Because
simply
the image was
accepting.
going back to the control.
I was
after
mistaken.
it was loomed.
I was mistaken. I was wrong. I'm accepting that what
Holy
you say
shit! I
happened.
think I just had a heart attack.
Brenda. You're wrong again.
So I'm accepting that what you said is what happened. That the dense sugar water collected at the top, and you showed in the progression of images sinking, which is what we expect.
No, from the control to the first lot of sugar water, it is looming.
No,
then, as he adds more in, it goes back to normal. What the control showed. There is no sinking.
No, the top image, which shows the most, the can above the
looming
foreground.
Shows the most looming.
Yes, that's looming because there's a different refractive index between the aquarium and the air.
Okay, all right. She's just going to go through the same thing again. I do have a serious question about the test that I'm about to do.
Okay.
Crow, were you done with your questioning, or did you have a follow-up?
Well, I've just thought about this, Brandon. Just one last thing. I'm going to recreate the first stage of that. So I'm going to pour some water in, get it up to the same height, and pour the first 1.4 kilograms of boiling sugar water in to get that immediate loom that we saw, right? But what I'm going to do is I'm going to put some dye in the water to colour it.
Yeah,
so I'm going to do it sort of like a deep blue. And then as I pour it in, it should stay on the top.
Well, I want to see pictures with just water.
You'll see a video of it.
Water without any sugar.
I'm going to do it tomorrow.
Water without any sugar.
Yes, yeah.
Covering the cups.
Brenda, I did that the second that on my last experiment. Anyway, Brandon, you want to discuss something?
Yeah. I just wanted to. I'm going to pour the sugar into the room temperature water. I'm wondering, would it be better to mix the sugar with cold water, maybe chill it overnight in the fridge, and then pour the cold water in?
Well, I think the known way to get a gradient at the bottom is to just sprinkle sugar in and let it just sink to the bottom and dissolve itself.
All right. Yeah.
Because once it dissolves, it stays in the water that it's in. It doesn't move anywhere.
Okay. All right, I'll go with that.
So I'm thinking that you probably won't get a clear gradient of blue at the top, but we'll see what the actual outcome is.
Okay. Right, listen, I'm going to round up, guys, because it's getting a bit late.
Damn it. I was waiting patiently. I was hoping to have a chat to you, Ranty. I'll probably have to do it another time.